All right, so this is lesson 3 in the statistics unit for Workplace Math 10. We're going to talk about outliers today. This is an important topic when looking at data sets because often you want to identify outliers and deal with those, okay, and understand how they're affecting the data set and if they're important to consider or not. So an outlier, let's define what that means first. So when you have a data set, an outlier is a point that's really different from the rest of the group. Okay, so we're going to look at some examples in a second, but what's really important actually, let's just look at an example. Let's say you were looking at how much money all of your friends earned over the summer. Let's say everyone had summer jobs and you were looking at how much money everybody earned. Let's say friend number 1 earned $250. Let's say friend number 2 earned $310. Let's say friend number 3 earned $280. Let's say friend number 4 got a really good summer job and earned $4,500. Okay, this would be an outlier because that number is so different from the other numbers. The other numbers are pretty close together. That would be an outlier. Okay, what we have to be careful of is outliers can really distort the mean. They can make the mean look really different from most numbers in the data set. Okay, so what we want to do in this case, if we have a data set with an outlier, we want to calculate something called the truncated mean. To calculate the truncated mean, we just remove any extreme outliers. That would change the mean a lot. Okay, so let's look at some examples of how we would do that. All right, so let's say we were looking at 3 or 5 real estate agents at a local firm, and this is how much their annual salaries are. So that means how much they're earning on average. So we have 86, the K just represents thousands. So 86,000, 92,000, 102,000, 15,000, and 95,000. So the outlier here is the 15,000. All of the other salaries are between 85 and 100 or so $1,000. The 15 is kind of an outlier. So let's calculate the mean and then we'll do the truncated mean. So for the mean, we would add up all of the salaries. So 86,000 plus 92,000 plus 102 plus 15 plus 95. Let's do that on our calculator. So 86 plus 92 plus 102 plus 15 plus 95. I get 390. And I'm going to divide this by 5 because there are 5 people. And what did I get again? 78. So the average or the mean salary is $78,000. But you can notice that 78 is not really like any of the numbers I see there. No person in this data set really earns close to 78,000. So it's kind of a skewed mean. Let's identify the outlier. So 15K is the outlier. Oops. And let's calculate the truncated mean. So the truncated mean is what happens if we don't include that outlier. So we just exclude it. So this is going to be 375. And we're going to do 375 divided by 4. $93.75. That is a much better, I would say, representation of the majority of these real estate agents at the firm. If you compare the truncated mean to the mean, this is a better representation of what most people are doing. So it says discuss whether the mean or truncated mean better represents the data. So the mean is skewed, we can say, downward, lower than, much lower than you would expect because of that outlier. So when I see the average salary is 78,000, that's not really representing the majority of the group. So we can say the truncated mean is a better representation of the salary for most of the group. Okay, let's look at example 2. So in a gymnastics competition, there are 6 scores given from judges after every event. The lowest score and the highest score are always excluded when calculating the average. So this is a typical thing they do in sports where there are judges. That way they can kind of, if there are any outliers, they're not really included. So calculate the average athlete's final score using the truncated mean. So what we want to do here is take out the lowest and the highest. So we want to take out the 7.1 and the 9.2. So we're going to calculate the rest. 7.8 plus 8.5 plus 8.9 plus 8.4. We're going to add all of those up and then divide by 4. Let's do that. So 7.8 plus 8.5 plus 8.9 plus 8.4. We get 33.6, and let's go ahead and divide that by 4 because there are 4 points here, 8.4. So this is the athlete's score. Why do you think this policy of removing extreme scores is often implemented in sports where winners are determined by judges' scores? So if there's one judge that is really high or really low, it's not going to throw off the whole result, right? So it's removes chances of bias maybe from judges or extreme scores. So the score is better represented by what the majority of the judges think and not by perhaps an outlier. Sometimes there's no outlier and then that doesn't really impact the score by truncating it. But if there are outliers, it takes away that opportunity.